Hey guys, just back with a second Linux tutorial. We're going to be continuing with the commands and going over the next part of that assignment. So just continuing with the C code, changing it to assembly language, moving the files around and stuff. So last time I didn't specify what sudo su was. Sudo su changes you to the root user. So sudo su changes you to the root user. Also, I've changed the mic quality to a better mic, so hopefully that helps. So hopefully it's clear for you guys. So sudo su changes you to the root user. We won't be using root today, hopefully. And then also, we'll do the command to how to check what shell you're using. So we'll just change. So we'll just type echo $shell. That tells you what shell you're using. So I'm using ZSH. You're probably using ZSH if you downloaded it recently. You might be using bash. So those are just administrative languages, it's the shell scripting language. ZSH is better than bash, apparently. It's more customizable. It supports more hash data structures and stuff. What else can we do? So last time I didn't specify how to get back to the home directory, so that's just done with cd. So we could cd to desktop. ls checks your it lists the directories. ls lists files and directories. I don't know if I believe I did mention that last time. I should have. So then now we've changed, so cd just changes back to home when you're not in the root user. If you're in the root user, it'll send you to root, so just beware of that. What else? So last time I had to reinstall Linux on my desktop, so hopefully I have everything. You guys should have everything if you watched the previous tutorial. We went over a bunch of commands. So let's make that directory then. So let's just go mkdir C codes. Just check we're in home. Okay, yeah, so we'll say mkdir make directory C codes. We'll do this again. Check ls. Then we have our C codes folder. We'll say cd C codes. So now we're in C codes. Let's see. I want to just create a file, a test file, so we can. Okay, let's not create the test file. Let's just create the C file and then move it back later on. That sounds like a good idea. So other commands. So copy command. cp space file1 space file2. So it copies file1 to file2. Remove rm space file1 space file2. Removes or deletes a file. Or just rm space file1, that removes that file. You can remove an empty directory with rmdir space directory name. We can list with long format, so we can say ls dash l. So I think that tells you like more information about the file, maybe the file size, permissions, all that. We can list the directories, the current directory with hidden files using ls dash a. So there should be no hidden files right now. So yeah, that's pretty much all that. We can maybe remove or delete a file. Can we create? We'd have to create it with the VI editor. Okay, so let's just say VI test.txt. So we're in command mode. Change to whoops. Okay, so now we're in insert mode. So we'll just say test file. Then I'll change to command mode. Save and quit. WQ. So yes, the save and quit file. So that should just go into C codes. Okay, so then let's say let's just say we want to delete the file. So we'll say rm test.txt. Okay, so the file is deleted. We can remove this directory completely, I believe. Oh. So you might have to do it here in the home. So we'll just say rmdir, remove directory. We'll say C codes. Okay, so we're already in that directory, so perhaps we'll try from here. We'll say rm dir C codes. There you go, the directory's gone. So let's create it again. So now we recreated it after deleting it. What else can we do? We can go over cat after, and then that's pretty much all we really need for now, for today. We'll do the move. Actually, no, there's one more. We'll move the file using mv. Actually, we could do that now. So let's go vi. Actually, where are we right now? Yeah, so we're here. So we'll say vi. We'll just create another test, 2.txt. I'll just say test file 2, escape, shift semicolon, WQ, save and quit. There's our test file, and then we'll say mv test2.txt. No, that's wrong. Did I do text? Okay, sorry, let's do this again. So let's say rm test2.text. Okay, so it's gone, and then we'll open the VI editor again. So VI, we did this in the last tutorial, so it's just VI opens a VI editor. When we do space file name, that creates the file, a new file, and opens it with the VI editor. So I'll just say test3.txt. I'm going to hit I here to get into insert mode. Test3. Then I'm going to hit escape to get back into command mode. Shift semicolon WQ to save and quit. Okay, so now it's in. Okay, wait. Okay, now it's in .txt. So then we're going to move it now. Let's just say. Let's say what we're going to mv move file. So we'll say mv test3.txt. So mv goes to, so we go mv file name space directory. So we're going to move test3.txt to C codes. Then so now the file's disappeared, we'll change to C codes, cd space C codes, ls. There's our file. We'll remove that. We'll delete it because we don't want the junk in that. It's just a test file, so we'll just delete it. So we'll say test3.txt. Whoops. rm test3.txt ls. Okay, well, no wonder what happened that time. Sometimes it glitches out, I notice, like, and then when you check it again it works, or it's already done it but it gives you an error message. So now there's nothing in here again. Okay, so that's pretty much it. We'll maybe go over 2 more commands in this video and then we'll finish up in the next one. Maybe 1 or 2 more after this. So we still have 2 commands. We'll do cat, which will display the contents, file contents of the stream. And then do we already move it? Yeah, we already moved it, so we just really need to just do cat. Or we could really just do it now. Okay, maybe we'll just do it now. So we'll say vi test4.txt insert mode. This is a text file. Escape to get into command mode. Shift semicolon WQ, save and quit. ls, check where it is. And we'll say cat test4.txt. This is a test file, so it prints the file contents to the screen without opening the file. Then again, we'll just remove that file. rm, so we called it test4.txt ls, and it's gone. Alright, so then now we'll continue with that other coding assignment. So I apologize, I forgot to open that, so let me just open my let me open that file with the codes on it. Not that you guys can see it, but just on my other screen. Okay, so this one's a while loop, so we'll probably go over these again in the C-Line IDE and step through them. For now, it's just an example, so let's just continue with that. So here we'll say, so we're gonna have to create a new file. So we'll just say vi, what's this one called? So just gonna call it while function. Maybe should capital it since it's a file name. So vi while function dot c insert mode. So here we'll include stdio.h. And we'll include stdbool standard bool.h, unless you want to really make your own bool class or your bool source file. So then we're going to need a void main, and we'll just have it empty for now. And then underneath we'll have our while function. So we'll just say void while function, camel case. Takes 2 parameters, so it's the same thing as last time, just we're converting the for loop to a while loop pretty much. So void while function int val1 comma int val2. So here we'll just have the same variables, int current val. What happened there? So int current val, and then we'll have int current val2. Int current sum. So we'll have an int current sum. Then we'll have a bool first pass. Set it equal to false initially, then we'll have a bool second pass set to false initially as well. And then we'll have another bool actually, so we'll have bool finished points to false as well. Because for a while loop it doesn't know when to stop. Or we needed to, I think we needed to count the iteration somehow, so that's why we have an extra bool here. Do we have, I think we had an extra bool here, so I know we needed an initial condition. So here we'll say while finished does not equal to, oh, does it really change the symbol? Okay, it does. Wow, I've never seen that before, so it just changes the not equals. So while finished does not equal to true. While finished does not equal to true. If first pass is equal to false, we'll say current val points to val1. So current val points to val1 if first pass is equal to false, current val points to val1. And we'll have underneath first pass points to true. And we'll have an else here. Else if second pass is equal to false. Open square bracket, we'll say if second pass is equal to false, open square brackets, and we'll say current val2 points to current val plus 1. So it's going to add 1, or increment by 1. So current val2 points to current val plus 1. Current val2 points to current val plus 1. Is that still in the same if? Okay, yeah, so it is. And then we'll say, so we got 10 last time as the answer. The answer should be 10 again if we input the same numbers. So here we have current sum points to current val plus current val2. So we have current val2 points to current val plus 1. New line current sum points to current val plus current val2. New line second pass points to true. another else here. What was that? Some kind of other language. So you'll have else, and here we'll have, so we have else, open square brackets, current val points to current sum. Current val points to current sum. That's it. New line. Then current val 2 points to current val 2 plus 1. New line. Current sum points to current val so 2 plus 1, and then current sum points to current val plus current val 2. So current sum points to current val 2. The current sum points to current val. No, I think I messed it up. No, current. Yeah, I did. Okay, so let's go back. So we have current val 2 points to current val 2 plus 1, and we'll have current sum here. Current sum points to current val plus current val 2. So current sum points to current val plus current val 2. Current sum points to current val plus current val 2. Okay, that should be fine. Here we'll have another if. Wait. Nope, we're in the same one still. Nested here, so we'll have maybe just space it out. So if current val 2 is equal to val 2, finished points to true. 1 square bracket, 2 square bracket, 3 square bracket, 4 square bracket. Below print f. So we'll print the string sum, shift semicolon, format specifier %d for int, /n, or is that / or backslash? Like backslash n, comma. Always get confused which one's forward and which one's back. So then here, put the comma before, after the quote, I think, and then we'll have current sum here. Yeah, that should be right, because we put the, yeah, that's fine. Because if we put the quote in here, it's going to print the quote, not actually, that's not actually the syntax. So we have print f, the string sum, shift semicolon, %d, new line, end of the string, then outside of the string, comma, space, current sum, shift semicolon at the end. That should be it. Just check for any mistakes that just kind of stand out. It's obviously better with a proper IDE. But this isn't too bad. I mean, the colors are okay, to be honest. Usually the colors have to be good for me, or else I just get too bored. That's just what happens to me. Like if it's all white or it's all one color, I just get super bored of the colors. It makes coding like boring. I prefer some kind of colors in the middle too, for like the variable names or something. Maybe keep the punctuation, like the brackets and the square brackets, the semicolons, another color too. Maybe in the future we'll make a coloring script for one of the IDEs, just to, like, how to make a custom theme. We'll code it. I think you just need like some kind of front end language to do that, like CSS or XML, something like that. So here we'll just, so we have our function here. We have our main, which is empty because we haven't called it. We still have to prototype it, so maybe let's just do that now. So we'll have here so here we're going to call while function. It hasn't been prototyped yet actually, so we should probably do that first. It's going to be wondering what's happening. So here above main, below these header files, we'll have void while function with the parameters int val1, int val2, semicolon on it, like almost like an interface, like you have to tag the semicolon at the end, like a Java interface. It's pretty much like an interface. You want to, that's what it is. It's like it's like a must include interface from Java pretty much. Like in Java you can have an interface if you want to, but in C it's required to have like a prototype, which is pretty much like an interface at the top. That's all it is. It's basically an interface because we added the semicolon at the end. So here we have, they should have done that. I think they should have done that in Java too. Actually, well, it's nice to have it optional. Apparently they're still using Java for a lot of things, even though like Android's stepping away from it. They're still using it in a lot of software. So here we'll have, in the main we'll have while. So here we'll have while function, and then we'll pass in 1 for, like we did last time. And then we'll just check everything. Void while function takes 2 parameters. Variables are all camel cased properly. False, false, false initially. While checks if it's not true. First pass is equal to false. Current val points to val1. First pass equal to true. If second pass equal to false. Current val2 points to current val1 plus 1 current sum. Okay, so I'm going to change to command mode now. I'm going to hit escape. I'm going to hit shift. Sorry. So I saved it just in case. So I did shift semicolon W. Now I'll do shift semicolon WQ, quits. LS, so it has while function.c. So now we will compile it. So we'll say GCC, then we'll say while function .c. Oh, there's a mistake in there. Okay. That's great. So we'll say VI, so we'll say LS. We'll say VI while function .c. So we're in the file again. We'll have to change. I didn't see what line it was, damn it. Okay, so there's a mistake in here. Where's the mistake? In current val, in current val2, in current sum, bool first pass, bool second pass, bool finished, all equal to false. While finished is not equal to true if first pass is equal to false. Current val points to val1. First pass is set to true, else if second pass is equal to false. current val 2 points to current val plus 1. Current sum points to current val plus current val 2. Second pass set to true, else current val so current val points to current sum. And we have current val 2 points to current val 2 plus 1. So we have current val points to current sum. Then current val 2 points to current val 2 plus 1. Then current sum points to current val plus current val 2. Current sum points to current val. What is missing here? Current val points to current sum. Current val 2 points to current val 2 plus 1. Current val 2 points to current val 2 plus 1. Current sum points to current val plus current val 2. If current val 2 is equal to val 2, finish points to true. Then no. Then yeah, so 1, 2, 3, 4 square brackets. Printf. Current sum, okay, that's great, so I'm not sure what it is. Command mode, shift WQ. So gcc while function dot c. Just a note, so we'll just try to see if it works. So dot backslash a dot out. Yep, I think there is an error with that file, so oh, so there, there is a, I think there's, yeah, there is still a, there's still an error. Line 30, 33, current val 2 undeclared. Did you mean current val? Undeclared. It's right up here. Oh, I forgot this semicolon here. There it is. Oh, still in command mode. There we go. So that should fix it, hopefully. So we'll hit escape back to command mode and then shift semicolon WQ to save it and quit. We'll try again gcc while function dot c. Then we'll say here, so now there's no errors, I think, so we'll say dot /a dot out. There you go, so we got 10. So it was the same answer as last time, which is a good sign. As the other loop, so we've transferred the loop from a for loop to a while loop this time. And then we can generate the assembly code, perhaps. So GCC space -c space -S space and then the file name while function.c. So GC, this is kind of a hard command to remember, right? Kind of. It's like not as easy as the other ones. So GCC space -c space dash, and then the capital S is kind of confusing to remember. Then space while function.c. That should generate the assembly code. We'll check with ls. So we have our .s file. And we can say vi. There's also another editor apparently called Nano that's better than vi, but vi is like the classic one, the classic Linux editor, command editor, which is pretty good to use. Either way, it works fine. But apparently Nano's better if you're looking to get farther into Linux. Nano might be a better editor to use. So here we'll say vi space, then we'll say we're going to open while function .s this time to open the assembly code. So here it is. This is assembly code. Perhaps we'll do the comparison later on. For now, we'll just kind of just view it. So there you go. We'll hit shift semicolon Q. It should be saved. So if I'll just go while, just to check, so I'll say while function dot s again. Nope, sorry, that was wrong. Vi while function vi first dot s. So we have the same file. So it's still there. And shift Q. So that should and there's a clear command, just I don't know if we went over that, but it clears everything. And then we'll just change back to the home directory and just clear it again. Okay, so there you go. So if you were looking at it, you wouldn't know what happened. So we hacked into the database and then we removed all their footprints. Just kidding. So there you go. That's the tutorial. That should be pretty much the rest of the commands. We did almost everything. We may have a few more commands. I don't know if we'll do file permission commands like chmod. Maybe I'll just tell you what we might do in the next one. Let's see. So what else would we do? Pretty much got the core of everything here at this point. There's also in the VI editor you can always use the command tail space file name, so it shows the last few lines of a file. Maybe not in the exact editor, you can do that from the terminal. That might show you a last few lines, either in the editor or in the just in the terminal. That'll show you the last few lines of a file, and then you can also do head instead of tail. That'll show the first few lines of a file. So we can then that's it. We did shell, echo shell, discuss what shell we were using. Environment variables, we can change those within. I think we'll probably just leave that for now. Editing paths. So interactive history, a feature of Bash and the other shell. So we can use up and down commands to show the history of the commands that we discussed. Or if you want to go back to a command, you just hit up and down on your keyboard to go back to a command or to find where you were. So I believe Bash was the default shell, user shell for most Linux systems. This was back in the day. They might have changed it to the new shell. The new shell is the ZSH shell. So that's the one that was default with Kali Linux for 2022, September 2022. The version of September 2022. So perhaps the default shell, maybe in Ubuntu and other Linux distributions also are ZSH now. So we might do actually another in the next tutorial, or once we finish the rest of the codes at least. We can use some commands like grep, G-R-E-P, string. So grep space string space file name, so we could maybe redirect. We could maybe perhaps we could use its redirects output of the above grep, so we can move the string to another file. So we may go over the grep command. We may go over pipes. That's pretty much it. Yeah, sorry, so this was it, searching for strings in files. So you can use the grep command to search for strings in files. Grep space string space file name prints all the lines in a file that contain the string. Prints all of the lines in a file. We could use perhaps a find command, find space search underscore path. Space dash name space file name. So we may go over the find command as well. Maybe the tar command stands for tape archive. Way to read and write archives. So we'll go over that perhaps. Maybe file compression, gzip and bzip. Looking for help commands. No, probably skip those. VI editor, we're done with that. Then that's it. So we may have pretty much maybe one or two more. So that's the end of the second Linux tutorial with the C programming as well. So hopefully you guys enjoyed the video. If you guys have any questions, you can let me know. If you guys want, you guys can subscribe to the channel if you want to see more coding videos or anything investing. And I'll see you guys next time. Take care.